Okay, so we're given the following equations. The quantity demanded is equal to 75 minus 0.25p, and then we're given total cost is equal to 90 plus 12q plus 5q squared. And this firm is operating in a industry which is imperfect competition, so it's not perfect competition. So from here, the question is asking us to calculate the profit maximizing output level. Well, to get that pi star output, which is Q, pi star Q, okay? So to get this, we know we need to set marginal revenue equal to marginal cost. We know this. So we've got to take this demand equation, we have to invert it so that we isolate P. So we'll bring this to the other side and bring this to the other side, then we'll divide by 0.25 and we'll end up with, let's see, P is equal to 300Q minus 4, oh, sorry, did I jump already? Minus 4Q. 300 minus 4Q. Okay, don't jump ahead here. 300 minus 4Q. Let's rearrange that formula. So now from here, what do we need? Well, remember, marginal revenue, this is the change in the total revenue over the change in the quantity. But we're going to use derivatives. So the first derivative of the demand curve, essentially. So let's multiply both sides by Q, Q, and Q. So now I have here total revenue is equal to 300Q minus 4Q squared. That's where I was going to jump to. And now from this point, let's take the first derivative with respect to Q to find marginal revenue. So marginal revenue, so let's see here, this says 1Q, Q to the exponent 1. We'll take the exponent, we'll multiply it by the coefficient, and then we'll subtract 1. So 1 times 300 is 300. Q to the exponent 1 minus 1 is Q to the exponent 0. Anything to the exponent 0 is 1, so that goes away. This is 2 times 4. So to the Q to the exponent 2 minus 1. So 2 times 4, that's minus 8. And Q to the exponent 2 minus 1, well, that's Q to the exponent 1. So now we have our marginal revenue. Nobody writes the exponent 1, there it is. Our marginal revenue is 300 minus 8Q. So I went from the demand curve, I rearranged it to isolate price. Then I multiplied both sides by quantity to get total revenue. And then I took the first derivative with respect to Q. Over here for total cost, let's get down to marginal cost. We'll do the same thing. Marginal cost, we'll take the derivative with respect to Q. Well, here this is the number 90. There is no Q. It goes to 0. So this is 1 times 12. That's 12. Q to the exponent 1 minus 1, that's Q to the exponent 0. Anything to the exponent 0 is 1, so we don't even write it. 12. 2 times 5, and then we'll subtract 1. 2 times 5, that's 10. Q to the exponent 1. Marginal revenue, marginal cost, let's set them together and solve for Q. 300 minus 8Q is equal to 12 plus 10Q. And we get Q is equal to, what did I end up with? I didn't even do the math. And let's just do the math here. Okay, so what do I have here? I've got, well, we better do it step by step. Okay, so we'll do this. We'll do 300 minus 12 is equal to 10Q plus 8Q. Okay, so 300 minus 12, that's 288. Is equal to 18Q, divide both sides by 18. And now I get Q is equal to 16 units. Okay, there it is. So the profit maximizing output level occurs at 16 units. Okay, now let's move on to the next example.